In this video, I'm going to show you how to graph a linear inequality, and then we'll get to in a couple future videos how to graph a system of linear inequalities. But let's just start with how to graph one line, and then we'll work towards two. So for the top of your paper here, it says two or more linear inequalities form what is called a system of inequalities. Now the inequality is just going to be your line. And then your symbol is not going to be equal to in this case. It's going to be like what you see here, maybe less than or equal to, or over here a greater than or equal to, or perhaps just greater than. And so beyond just drawing the line, you have to do what's called some shading. So part 2 here kind of talks about that. A solution of a system of linear inequalities would be any ordered pair that is a solution to each inequality of your system. And the graph of a system of inequalities is the graph of all solutions of the system. And so how you're going to show all solutions would be to do some shading, just like when you did shading on a number line. And so just kind of quick review back what we did in chapter 3 when we would say x is greater than 3, you'd have your number line and you'd see where 3 was. Let me start with 1, 2, and then 3, and you'd circle your 3 and then you'd shade. So if you kind of remember that, we're going to do something similar, but now an equation, a linear inequality. Okay, so now here are our steps. So steps for graphing a linear inequality. Number 1, graph your corresponding equation. Number 2, use a dashed or a solid line depending on your symbol. Now a dashed line, these are dashes, it's probably hard to see, but look on your paper. A dashed line you would draw for inequalities that are strictly less than or strictly greater than. And the points on that line will not be a solution. And so I'm just going to kind of highlight that because that's important. And then part B here, solid lines are going to be drawn for when you have the symbol that has the equal to. And then points on those lines are solutions. And then number 3, shade the appropriate area to show where the solutions are. So that's the shading that I had kind of mentioned up here, like when you did shading on a number line, but now the function. So taking a look here, it says y is less than 4x minus 5. You're going to graph this like you would if the symbol here was equal to. And so I'm going to start with my y-intercept, which is called your b, and your y equals mx plus b, and that's negative 5. So I'm going to put a point down here on negative 5. And now I'm going to follow my slope, which is 4, or 4 over 1. So if my slope is 4 over 1, we're going to go up 4 and right 1. And you should always go to the right here for your direction if you can. Otherwise, you'd have to go backwards. But go, if you can, start going always to the right, the bottom number here. So we're going to go up 1, 2, 3, 4, and right 1 for another point. Up 1, 2, 3, 4, right 1 for another point. 1, 2, 3, 4, and right 1. And I can't go up anymore, but let's see if I can go backwards. 1, 2, 3, 4, down and left 1. So completely backwards, down and left. So now what I'm going to do is connect those points that I have. And I notice that my symbol here is strictly less than, and so I know that I need to draw a dashed line, because dashed is used for these symbols. And so what I want to do is just kind of not totally connect my points. Now points on this line would not be solutions, like it mentioned here. And then it says shade the appropriate area to show where your solutions are going to be. This is how I find what area to shade. I pick a point that's not on the line and try to pick an easy point. I mean, one of the easiest points would be to test a point like 0, 0. And what we're going to do is plug a 0 in for our y value, a 0 in for x, and see if we get what is called a true statement. And if it is true, we would shade the side of the line where 0, 0 is. But if it is untrue, we shade the opposite side. So I'm going to plug in here, is 0 less than 4 times 0 minus 5? Or is 0 less than 0 minus 5? Really what they're saying then is 0 less than negative 5? And my answer would be no. 0 is not less than 5 here. I'll just kind of emphasize that a little bit more. 0 is not less than negative 5, and so what I'm going to do is shade the opposite side. So 0, 0 was not a solution, and so don't shade that side. Now let's try it again here, but notice how my function is a little different, and then now I have an equal to part here. So equal to symbol means we are going to draw a solid line for these symbols. So I'm just going to remind myself that my slope here is positive 1/3 and my b is -2. So in this line, I'm going to start at -2 on my y-axis, and I'm going to go up 1, right 3. 1, 2, 3. Up 1, right 1, 2, 3. 1, 2, 3. And now I'm going to continue and go backwards here, down and left. And now I'm going to connect these points with a solid line. And again, to know which side you want to shade, test a point. So I'm going to pick, again, 0, 0, because it's not on the line. And I'm going to plug in, is 0 greater than or equal to 1/3 times 0 and then -2? Or is 0 greater than or equal to 0 minus 2? Is 0 bigger than -2? Yes. So I will shade the side of the line that has 0, 0, which would be above the line. And any point in the shaded region and on the line would be a solution for this picture. But in this picture, any point inside the shaded region would be a solution, but not points on the line. And that's because we learned up here points on a dashed line are not solutions, but on a solid line they are. But for sure, any point in your shaded region would be what is called a solution to your system, or your one inequality. And then just, like we did shading here. So what numbers are bigger than 3? There's going to be a lot. And so you're going to have a lot of solutions, which is why we need to do some shading.